Welcome to 4.5 Determinants. Today we're going to evaluate the determinant of a 2x2 and a 3x3. So let's start with some vocab. A determinant is a square array of numbers or variables enclosed between two parallel lines. So we got a matrix here, 3, -1, 2, 5. The determinant of this matrix would be the DET, determinant of the matrix 3, 2, -1, 5. A second order determinant, the determinant is of a 2x2. Third order determinant is the determinant of a 3x3. So our key concept here is that the value of a second order determinant is found by calculating the difference of the products of the two diagonals. So we multiply A times D, which is the first diagonal, and then we subtract the diagonal B times C. So an example here, find the value of each determinant. The definition of determinant, we're multiplying -2 times 8, and we're going to subtract 5 times 6. So we multiply, we get -16 minus 30, and then we simplify, we get -46. So our determinant of -2, 6, 5, 8 is -46. For part B, we have 7, 4, -3, 2. We're going to use the definition of determinant. 7 times 2 minus 4 times -3. Multiply, we get 14 minus a -12, which we simplify and we get 26. So that's determinants of 2x2, that's second order determinants. Our next concept is third order determinants. We're going to use expansion by minors to solve this. To use expansion by minors with third order determinants, each member of one row is multiplied by its minor and its position sign, and the results are added together. The position signs alternate between positive and negative, beginning with a positive sign in the first row of the first column. So our third order determinant here, we would do A times the determinant E, F, H, I, then minus B times our determinant of D, F, G, I, plus C times the determinant D, E, G, H. So let's look at expansion by minors here. We want to find the determinant of this 3x3. So we're going to decide which row of elements to use for the expansion. For this example, we will use the first row. So the first row, that's our A, B, or C. So we're going to do 2 times the determinant, 5, -4, 9, 0. Then we're going to do -7 times our determinant of -1, -4, 6, 0. And then plus a -3 times the determinant of -1, 5, 6, 9. So that's our expansion by minors. Then we're going to evaluate the 2x2 determinants. So we're going to do 5 times 0 minus -4 times 9. We're going to do -1 times 0 minus -4 times 6. And then finally we're going to do -1 times 9 minus 5 times 6. So that gives us here, so 5 times 0 was 0, -4 times 9 was -36. We get 0 minus a -24, and -9 minus 30. We're going to then simplify and then multiply, and we get 72 minus 168 plus 117, which simplifies down to 21. Another method for evaluating a third order determinant is by using diagonals. So step 1, we begin by writing the first two columns on the right side of the determinant. Step 2, we next draw diagonals from each element of the top row of the determinant downward to the right. We find the product of the elements on each diagonal. Then we draw diagonals from the element in the third row of the determinant upward to the right. Find the product of the elements on each diagonal. So this is what it looks like below. And then step 3, to find the value of the determinant, we add the products of the first set of the diagonals and then subtract the products of the second set of diagonals. The sum would become AEI plus BFG minus GEC minus HFA minus IDB. So let's see the diagonals done here. So we rewrite the first two columns to the right of the determinant. So that's what we have here. We rewrote the columns. Then we're going to find the products of the elements of the diagonals. So we're going to do -1 times -2 times 2, which gives us 4. Then we're going to do 3 times -1 times 0, which gives us 0. Then we're going to do -3 times 4 times -5, which gives us 60. On the right side here, we're going to do 0 times -3 times -2, which gives us 0. -5 times -1 times -1, which gives us -5. And 2 times 4 times 3, which gives us 24. We're going to add the bottom products and subtract the top products. So we're going to do 4 plus 0 plus 60, minus 0, minus a -5, minus 24, which gives us 45. So the value of the determinant is 45. Our key concept here, the next one, the area of a triangle having vertices of A, B, C, D, and E, F is the absolute value of A, where A equals 1/2 times the determinant of A, C, E, B, D, F, 1, 1, 1. So let's see an example of finding the area of a triangle. So we have -1, 6, 2, 4, and 0, 0. So we're going to create our first let's look at our area formula. We're going to do 1/2 times our x coordinate, -1, then 6. Of course, the third column is always going to be 1. Then we do 2, 4, 1, 0, 0, 1. And we're going to do 1/2 times the determinant of this. So we can use expansion by minors, where the top row are our minors. So -1 times the determinant of 4, 0, 1, 1, minus 6 times 2, 0, 1, 1, plus 1 times the determinant of 2, 0, 4, 0. We're going to evaluate the determinants, the second order determinants. So we're doing 4 times 1 minus 1 times 0, which is 4 minus 0. 2 times 1, which is 2, minus 1 times 0, which is 0. 2 times 0 is 0, 4 times 0 is 0, so 0 minus 0. And we can simplify and then multiply, and we get -4 minus 12 plus 0 inside. Of course, we're going to take half of that, simplify. It's 1/2 of -16, which is -8. Remember that the area of a triangle is the absolute value of A. Thus, the area is the absolute value of -8, which is 8 square units. That's it for determinants. Good luck on the practice.